Hi, so welcome to another video. So today we're going to be talking about molecular orbital theories. So we're going to be talking about the orbitals for the whole molecule and not just the individual atoms. So when the two atoms come together, their atomic orbitals will overlap. And we're going to look at the theory on how we arrange those electrons in the molecular orbitals. So a whole new set of orbitals that are created when they come together. So first of all, let's start with a very simple molecule. So let's look at H2. So we've got two hydrogen atoms. They're coming together. They've got that front-on overlap of their s orbital, their 1s orbital, and we're going to write out the molecular orbital and determine the bond order. So each hydrogen atom will have one electron. So if we've got two, we're going to have 2 times 1 electron. So we're going to have 2 electrons, one that comes from one hydrogen and one that comes from the other one. So when they come together, the original electron that sits in both of the hydrogens 1s will go in together and we will have 2 molecular orbitals that are produced. We've got the 1s that's the bonding 1s and we've got the antibonding 1s. So the bonding 1s has the lower energy. So this is a sigma bond. So it's got the lowest energy conformation and the antibonding has a higher energy requirement to fill. So if we were to put the 2 electrons in, so following the rules, we fill the lowest energy first and we've got 2 electrons, so to be 1, 2. So they would just both sit in that bonding sigma 1s. There'll be none in that antibonding. If we were to have more than 2 electrons, then we would start filling the antibonding orbital. So to work out the bond order, so the bond order equals half the total number of bonding electrons minus the total number of antibonding electrons. So for this one here, I would look at my bonding, how many electrons are in here, write it in bonding, and my antibonding, how many electrons are in here, and that would be that part. So for here, I've got 2, so it'd be half. I've got 2 electrons in my bonding and I've got 0 in my antibonding. So it'd be half of 2, so it would equal 1. So that would be the bond order. So a bond order of 1. So 1 is a single bond, 2 is a double, and 3 is a triple. Okay, so depending on the value that you get out, you'll know what kind of bond is achieved when those atoms come together. Now you can have fractions, you can have not whole numbers, and this is really, really important information that this particular theory can give us. So that is just standard H2. Now let's look at H2 minus. So now we've got another electron that's adding. So H2 minus, okay, so now I've got an extra electron that's going to be added to it and it's overall to the whole molecule. So if I've got those 2 1s's coming together and then I've got another electron that's given us this overall negative charge, that now sits in that anti-bonding. So how's this going to change my bond order? So my bond order now will be, where can I fit this? Okay, so bond order, let's do it here. Bond order, and this is for H2 minus. So it would be equal to half the number of bonding, still got 2 in there, minus the one that's bonding in the anti-bonding. So we've got 2 minus 1, which gives me 1, and half of 1 gives me 0.5, or half. So now I've got less than 1. So that means that there wouldn't be a single bond occurring now. Let's have a look at this a little bit further. So if I have H2 minus, so I've got, this is my molecular orbital diagram. Now, if I have one of those electrons becoming excited, okay, So we've got an excited one now. So what happens in an excited state? We have the promotion of an electron in a lower energy orbital to a higher energy orbital. So let's promote one of these up to the top. So now I've got 2 in the antibonding and 1 in the bonding. So how does that change my bond order? So this will be my excited H2 minus. So I've got half, and now my bonding electrons, I've got 1. My antibonding, I've got 2. So I've got half of 1 minus 2 gives me minus 1. So I've got minus 0.5 now. So because it's a negative value, it cannot exist. Okay, so this excited state of H2 minus would not exist.